The next example is about graph motion interpretation. As you can see on the screen, you have the velocity time graph that represents the motion of a metro rail train from Bosman Station towards Centurion train station. Right, you can see this is the graph clearly there with an indication of points A, B, C, as well as the values of velocities on the y-axis and the values of our time taken on the x-axis. Right, at the bottom there we have got the questions based on the graph plotted there. The first question there is asking us about how long did the train move with constant speed. We will have to get the answer from the graph there. Now, the second question says, after how long did the train start move at constant velocity? Now, if the train moves at constant velocity, there's a time whereby it started to do that. We have to get it from the graph as well. Now, the other thing, number 3, says, show by calculations that the train accelerated constantly by 5 meters per second squared. Okay, that's another thing. And then the fourth one says, show by means of calculations that displacement covered by the train during the first constant acceleration is 22.5 meters. Right. Okay, to find the answer for the question number 1 asked, we must look at the graph and identify the points at which constant velocity is represented. Between point A and B is where the train was moving at a constant velocity. And since the question says how long, then we must check the time interval from the point A to point B. It is from 3 seconds to 8 seconds. Now, it takes only 5 seconds from 3 seconds to 8 seconds. That means the train has maintained the constant velocity for 5 seconds. And then the first question has been answered now. Now let's answer question number 2, which asks us as follows. How long did the train start moving at a constant velocity? If you can look at the velocity time graph here, you will notice that during the first second, the train was accelerating, as well as the second, the train was still accelerating. And on the third second, that train is now starting to maintain the constant velocity. So in conclusion, we may say the train started maintaining or started moving at constant velocity after 3 seconds. And instruction number 3 says, we must show by means of calculation that the train accelerated constantly by 5 meters per second. Now, since we know that the acceleration is the rate of change in velocity, we can take any value of velocity within the constant acceleration points and multiply that value with its time value in order to get the value of the acceleration that we need to get. Let's take our velocity of 15 meters per second and divide it by its time interval, which is 3 seconds. Now, if you divide 15 by 3, the answer is 5. This means an acceleration is 5 meters per second squared. Even if you can use the velocity 10 meters per second, you will still get the same answer as 5 meters per second squared, since you will have to divide the velocity of 10 by 2, and that 2 which is its time interval. The same applies to the velocity of 5 meters per second. The fourth instruction, which is the last instruction in this example, instructs us to show by means of calculation that the displacement covered during the first acceleration process is 22.5 meters. We have a way of proving that the displacement covered is 22.5 meters, and that way is usage of area formula. If you look at the inclination line that represents the constant acceleration on our graph there, you will realize that the line has formed the triangle with the x-axis on which our time values are plotted. Therefore, we will use the formula of an area of triangle. If I may state it now, it will be S equals to half times velocity times t, which is S as for displacement must be equals to half times velocity, which is v, times time, which is t. Our velocity to be used is 15 meters per second, and time to be used is 3 seconds. After substituting v by 15 and t by 3 in the formula of area of triangle, we will have S equals to half times 15 times 3. And half times 15 times 3 equals to 22.5 meters. Now we have shown and proven that the distance covered during the first acceleration is 22.5. Thank you. Now here is a task for you to do. The task is about the dump truck of mass 1,800 kg loaded with coal of unknown mass and moving at a constant velocity of 8 meters per second for a period of 7 seconds. Then it appears that again in the statement that it decelerated until it stops. And then after stopping, it appears again that the truck started to reverse. It has reversed for 4 seconds at acceleration of 0.2 meters per second square. Right, under the statement given up there, we are facing an instruction that instructs us that we must draw a velocity time graph that represents the whole motion of the truck and calculate the following. We have got 5 items to calculate. The first item says the mass of the coal loaded in the truck bucket. If the mass of the coal is 45% of the mass of the truck. The second item to calculate is the final velocity of the truck at the fourth second during the reverse motion. Now the third item to calculate is the weight of the whole system. It means the weight is the sum of the weight of the truck and the sum of the weight of the coal. And then the fourth one is the work done by the truck on the 6th second, or of the forward motion. And then the 5th item is the displacement covered by the truck when it reverses for 4 seconds. Those are the items that you should find or you should calculate. And if you did your calculations correctly, answer number 1 must be 800 kg. Answer number 2 must be 0.8 meters per second. Answer number 3 must be 25,480 kg or 25.6 tons. Item number 4 must be 3.4 kilojoules. Answer number 5 must be 3.4 meters. If you did your work well, then that would be cool. And then if you don't get the right answers, those answers that I've just mentioned right there, don't hesitate to contact me. I will come up with better elaboration and explanation. And then we still have got another work to do here based on the motions on the graph. Here is the graph here, you can see. It shows the velocity time graph, which has got the values of velocity on the y-axis and values of time on the x-axis. Right there, you can see everything has been plotted. You just have to interpret the graph, and you determine the average velocity of a moving coin, or of a moving object, it's to determine the average velocity of a moving object represented by the graph above. And the answer for this is 12.5